if they don't stay.
I got tabs, but
They don't fit.
well, you can't even open it. You can't even open it. Sorry.
You're good. That is odd. Yeah, that's really strange. I've got some tape if you want to use it.
It's okay. They give you these things.
Yeah,
Tabs.
it might be a printing error.
Yeah.
So, all right, guys. Are there any questions over the homework? Because we didn't have homework assignment yesterday. Questions, homework.
Oh wait.
I mean, not technically yesterday, but 1.2 or 1.1. Because we didn't have an assignment yesterday.
Where did you get your shirt? I want more running shirts.
I got this a while ago.
I know I can make stuff, but I want like how they screen print it. I want screen print.
Because I think this was from one of the basketball seasons. So those shirts should come up around October or so. Not October, November, December, when they start doing their fundraisers. In next week or so. I don't know.
Why are you worried about that? No, I just didn't know if we had to do it because last year we had to do it, but I didn't know if that was like required.
You ever see
That, I'd have to check with Miss Ferris.
Are you on it?
Yes. Brooklyn. What? Appleton Brooks. Rugas. Marijuana.
Questions?
I've never touched marijuana in my life.
Marijuana.
Sorry.
Questions over the homework?
Yeah.
Questions over the homework?
Homework? Oh yeah.
We didn't have homework from yesterday, but if there's questions on 1.1 or 1.2. Yes. Yes.
Oh yeah, because we got.
So there's several different things we talked about yesterday, applying horizontal, vertical, and our reflections. So we apply a horizontal translation. We're talking about f of x minus h. This is our up or down. We're moving the function up. Yeah, sorry. I'm getting ahead of myself. F of x minus h is our left or right. Now, vertical is our f of x plus. Now, this one is indeed our up or down. Then the other one we went over is reflection. Now we have two. We have one across the x-axis. And that is indeed negative f of x. And the other one is across the y-axis. F of negative x. And really we stick with these here. I would stick with these notations to really apply these transformations. Because if we use these and plug the values into their corresponding spots, we'll be able to get our exact transformations that we need. Now the two new ones that we have today are, the first one is our vertical stretch slash shrink. And the way that we denote this is A times f of x, where A is the amount that we're stretching or shrinking. Yes. Kind of like with horizontal, where we're going left or right, we still used f of x minus h if it went left or if it went right. The same is true for vertical, up and down. We still used f of x plus k, no matter if we were going up or if we were going down. So it'll tell us a vertical stretch of 2, so the value of a is going to be 2. If it said it's a vertical shrink of 1/3, the value of A is 1/3. Questions on this here? Now the other one we have is horizontal. Yes. Stretch or shrink. And this one is going to be f of A times x. We have to flip the value. Because inside the parentheses are absolute values. It's going to be the opposite of what we think. So if they tell us for this here that our horizontal stretch is by a factor of 2, what we're actually going to plug in is 1/2. If they told it was a horizontal shrink by 1/3, we'd actually be plugging in 3. And this is given to us in the descriptions that we have, because the top one, horizontal stretch or shrink, the graph, so again, f times A of x, which we wrote on the previous slide, is a horizontal stretch or shrink by a factor of 1/A of the graph this here. So we have to flip it. We've got to do that 1/. We have to flip the value to get our actual amount. And that's the kind of trick with these horizontal stretch or shrink. Questions on this so far? So we're good with this here so far, yes? Okay. So again, it's kind of the opposite of what we think, and that's kind of, I made that connection with that. Our horizontal stretch and shrink is our f of AX, and vertical is a f of x. Now this is going to make a little more sense as we do these. There are going to be part of the notes I'm going to have you change because I kept forgetting to alter them. Because in years past, not last year, I just went and skipped over horizontal stretch and shrink because we do have that little bit, it's a little bit tricky there. But I feel like we can do that because if we just flip it, we're good. Now this first one here, we want to write a function, g of x, who's, not g of x, h of x. Got a little too accustomed to having g of x first. H of x, whose graph is a vertical stretch of the graph of f by a factor of 2. So there's 2 ones we can use for vertical stretch and horizontal stretch or shrink. We have a times f of x, a f of x, or f of a times x. Will a be in front or inside the parentheses for this here? That's going to be out front because a times f of x is our vertical stretch or shrink. F of a times x is our horizontal. Now the question is, what is the value of a? So what's our factor that we're stretching this by? 2. So the value of a is? Yes. Taylor? Yeah.
It was funny. I was still thinking about the way she reacted to that joke. It was funny. No, it was just like the fact that he didn't get it at first, and as soon as he got it, he just like exploded.
I still don't get it.
We can explain a little more later.
Do you always like memorize all those jokes for the like the same years?
Sometimes they come back to me, sometimes I forget.
Really good one, Will.
Yeah.
The One Direction joke.
Yes.
You don't remember that? It was like we were talking about like lines, right? And
Yeah, I can go over those here in a minute.
it was funny.
So let's get through this first, and then I'll do those. So f of x. So we plugged in 2 for a. So we have 2 times f of x. Now we just need to replace f of x with its function, kind of like what we did with our reflection across the x, where we just replaced f of x with our function here. So we'd have the absolute value of x minus 3 minus 5. And just like with the reflection across the x-axis, we're going to multiply through by our 2. Because instead of multiplying through by just the negative, we'll multiply through by the 2. Now the 2 will not go inside the absolute values. It'll stay out front. So we'll just have 2 times the absolute value of x minus 3. Now we need to do 2 times negative 5, which is negative 10. And that's it. Yes? So really what I'm looking at, so looking where things go is this or to here.
So A is the factor, which is
So you're wanting to know?
Parentheses are
Okay.
okay.
So parentheses right here.
Yeah.
So I put parentheses around when we insert something in. So when we replace f of x, we're replacing f of x with its function, yes? So when I put it in, I put parentheses around it because this 2 is being multiplied by the function f of x, by the entire function. So I'll put the parentheses around it to remind myself the 2 is not multiplied by just the first part. It's multiplied by the entire thing. So we put the parentheses around it when we insert it in so that stuff like that does occur. And then we would distribute through. On previous ones, where it was just say x minus 3, and we put in something for x, let's say just 2x, is there anything in front of the x? No. So we'd still put the parentheses around it, but because there's nothing in front, there's nothing to multiply it by, so it just becomes 2x. We kind of drop it. You all see the kind of difference between those two? Because if we hadn't had the 2, we could have just dropped the parentheses and just had our function. But because the 2 is there, we need to distribute it through. Does that make more sense?
Okay, so then like yesterday,
Mhm.
those ones, so like the f x minus h,
Mhm.
you would put something there and then put something there again.
Yes.
I don't know.
So let's look at this one here, because this will be similar. Because one of the things for this one, it does say vertical on your note sheets. We're switching it to horizontal. Yeah, so what I did is I erased horizontal and then manually typed vertical up and put it in its place. But since then, I want to actually cover horizontal. And this is actually going to answer that question. Is that, so let's make sure G of x. Now, since we're talking about horizontal stretch or shrink, this time we're using f of a times x. Because horizontal stretch and shrink is our f of a times x. Now, it says a horizontal shrink of the graph by a factor of.
So is the 1/3 going to take the f, or is it going to go to the
It will go in there, but we need to do one thing to it first. We have to flip it
Is that because it's a shrink or is it because it's horizontal?
because it's horizontal. Now, the thing with horizontal, what we're talking about, stretch or shrink, if we're talking about a stretch, especially vertically, it means along the y-axis it's increasing faster. If it's a shrink, it means vertically it's increasing slower. We decreased the amount it's increasing. Horizontal is talking about the x-axis, left and right. And to adjust kind of the fact that it's inputs, we have to do this flip. Because it's not the exact same, but if we increase something faster along the y, it means the x is getting closer together. So a horizontal shrink is going to look something similar to a vertical stretch, technically, not technically, but kind of. So we have to have this flip. Yes.
Wait, that's with all horizontal shrinks?
Horizontal stretch or shrink.
Oh,
We got to flip it. So if it's a
vertical.
So if it's
Not
horizontal,
stretch and shrink, yeah. We have to flip it. This is the only one with any of these here that we have to do anything to it first. Because horizontal left and right, because if it's negative, we plug it in as negative and the minus takes care of it. If it's positive, it looks negative. So as if it was -4, the negative and negative make a plus, it's kind of flipped it. Does that make sense? If it had been +2, then we moved to the right, it would have been -2. We have that switch of signs. It took care of that. The change for this here does not happen just in the function itself. So we're taking care of that first. Which means A is not 1/3, but A is 3. So one of the things, especially if you notice when we wrote it down the first time, I put make sure to flip A. I would put that down as a note. Flip before you plug in, and that's only with horizontal stretch and shrink. That's the only one we have to do this with. Okay. Questions on this so far? Because that's the only real tricky thing with horizontal stretch and shrink is that we've got to flip the value that they give us first, and then plug that flipped one in. Okay. Now I think this is coming to where your question was. What do we do next? So they told us f of x is this here, yes? So when I have x inside here, this is x. Do I have just x here? So I've replaced this x with, so I'm going to replace this x with, yeah.
So minus x minus 3x.
Well, what about the f?
So this is f of x. It's saying this function here, we're still using it, but instead of having x, we have 3x. It's just naming the function. It disappears. Because f of x is just another way to say y. Because y equals for our normal functions. So we're just defining this function by f of x. It's a way to name it. So we're saying that this function, if I say f of x, we're talking about this part here. So we're just changing the x to.
Would you say 3 and then the line and then it's x?
Yeah, so we'd put
Oh, wait.
absolute value. Wherever there's an x, we're removing it and putting in 3 of x. Minus 3 minus 5.
I did it differently, but I think like it too.
We can drop the parentheses because there's nothing in front of them. There's just 1, so we just get 3x. And we get this here. Now, what we're doing is similar to if I don't need G. If I said f of 3, I said to evaluate this function as f of 3, well, we replaced x with what? Well, 3x in that one. Here, just 3, so that means I'd go through this function and replace every x with what? And then we would just evaluate. What we're doing here is similar, but instead of just having a number, we have a number and a variable. Does that kind of make sense? Because it's more or less that we're x in the general spot is just kind of a placeholder. We're saying f of x is this function. That any of the inputs are going to show up here. So anything we put in this spot will correspond over here, wherever x is in the equation. But normally we only have it once in all the ones we've done. Does that answer kind of that question? Because sometimes, like here, we can have 2 terms that go in that spot. It could be 1, it could be 2, it could be 3. It's just, that's where it's going. One way I've seen it put is that written it as f of box, just where we could put it in an input spot, is equal to if I put a 2 in here, What's going to go in this one?
This box is X.
Yeah, box is just X, because I could put an X in the box, which means this box is also X. Is that kind of, all we're doing is plugging into each box. Oddly enough, the first time I saw that kind of method of writing it was in college. Yeah. Questions on this so far? Let's look at this next one. Write a function whose graph is a stretch of the graph of x by a factor of 5.
Wait, are we doing vertical?
Huh?
Are we doing vertical?
Oh, I'm switching it. Yeah. I did fix the note sheets for next year, but that doesn't help y'all. So horizontal stretch, horizontal stretch. What do we have to do to the 5? We have to flip it to 1 over 5. So which starting function setup would we do? We'd say g of x equals what?
1/5 minus what?
F of,
Wait, F of AX.
because vertical stretch and shrink is a, f of x. Horizontal is f of ax. Now I'm not expecting y'all to memorize these. I would make sure that you have them written out and referenced back. Because again, you can use the review sheet on the test. I would have those.
When we do the review, are you going to write all this just so we make sure we have it right? Okay, let's go back to our own notes.
If it's not down, I will make sure to cover it and have it written up there correctly. So if I do forget, remind me. I'll put it back up there. Now at this point, we can replace a with 1/5. Because we can plug that in for a. Now I'm going to write this off to the side. You can write it underneath, because I still want to have the main function on the screen. So now we have f of 1/5 x. Well, we've replaced x with 1 over 5 times x, which means every x in the function is now going to be 1 over 5x.
So you replace the F with the 1/5.
So yeah, so this here, so this is now this, yes? Which means every x over here is going to become 1/5. Yes. 1/5 x minus 1.
That's it.
Yeah.
Sure you did.
Got it?
I thought we were supposed to replace the outside.
If it's vertical.
So you just did this horizontal.
Yes. Because if it had been the original vertical, we would have just used the 5 for the a outside and gone that way.
The next one is vertical. Can we do vertical?
Yes. Questions on this horizontal before we look at the next vertical? Well, hopefully the next one goes up. That's a lame joke. We can, or we can leave it as a decimal. So here, h of x is a vertical shrink of the graph of f by 0.25. So since we're talking about vertical stretch or shrink, we're looking at a f of x, because that's the one we use for vertical stretch and shrink. Now the value of a would be what? 0.25. We don't have to do anything to it because we're talking about a vertical. Yes. Which would be our 1/4 f of x. So I'll write them both, and as a fraction, one is a decimal. Now, f of x is still f of x, yes? We didn't do anything inside the parentheses with f of x. It's still the same, which means I can just replace f of x with its function. So we don't have to do anything to it. So this is still going to be absolute value of x minus 1 plus 2. Yeah. Because we do have something in front of the parentheses, yes? If we didn't have anything in front of it, we could just drop them. And when we drop them, really what we're doing is multiplying everything by 1, and multiplication of 1 doesn't change anything. Now, the 0.25 times an absolute value is actually just 0.25 times the absolute value of x minus 1. It won't go inside the parentheses, it just stays there. Now, if you're multiplying with the 1/4, it'd just be 1/4 times x minus 1. It just goes out front. But we still need to multiply the 0.25 by 2. Yes. And 1/4 times 1/2, or 1/4 times 2 would be 1/2. You just need to pick one. You don't have to do both. Leave it as decimal, write as fraction. I will take either one. I'm not expecting you to do both. So if you like fractions better than decimals, do it as fractions. If you like decimals better than fractions, do it as a decimal. Whichever one you want to do. Questions on this here? Vertical shrink by a factor of 1/3. Since it's vertical, we have a times f of x. Now our value of a in this case is 1/3. Did we do anything to f of x? No. We could write it back out as f of x, or we could just plug it in. As I've been doing in multiple steps, we don't necessarily have to do it in 2 different steps. We can do it all at once. If you feel more comfortable doing it 1/3 times f of x and then doing this step, do that. Because that's part of our function. And the last thing we need to do is multiply through. Now our 1/3 times the absolute value of x is going to be 1/3 absolute value of x minus 1/3 times 3 is, because it was minus 3. So we still have our sign. Questions on this here? You feel pretty good with these here, for the most part? So I'm going to skip that one for now, because what I want to hit last are these here, these combinations. Combining transformations. So the first one we're looking at is let G be a vertical shrink by a factor of 0.25, followed by a translation of 3 units up of the graph f of x equals x. When doing these here, do them one transformation at a time, like we've been doing. Because up to this point, what we did yesterday, most of the day today, is we've done it one transformation. We've done one vertical stretcher shrink, horizontal stretcher shrink. We didn't do reflections today, but we did reflections yesterday. We either reflected just over the x or just over the y. We just moved it up or down, or just left or right. We did one. And what we're going to do today, or not right now, is we'll do them one at a time. So the first one I'm going to call h of x, because our final one we'll name g of x. So the second one, or the last transformation that we'll do, we'll use g of x for. But we're going to do these transformations, one in the order that they show or appear in the sentence, and we have two. So the first one we're going to do is the vertical shrink by a factor of 0.25, AF of x. We're not going to worry about the down or up 3 units yet. We're going to do this transformation first. Yes. So we'll have 0.25. And we can do f of x, or we can replace it at this point. Now, what is f of x equal to? X. So we're replacing f of x. Yeah, so 0.25 times x is 0.25 x. Vertical shrink by a factor of 0.25, done. Well, since we're multiplying. If it was addition or subtraction, yes. We can't combine them.
What if it was the absolute value of x?
Then it'd be 0.25 times the absolute value of x. And that would be okay. Now the next part is what? Followed by a translation of 3 units up. And right, and that's the last one, so we'll call this next one is equal to. Now the normal form we had was f of x plus, are we applying this to this f of x anymore? What are we applying it to? This one down here, yes? So instead of saying f of x, I'm going to say plus. Okay. Because again, f of x, h of x is just referring to which function we're applying it to. So it's not stagnant, and it always has to be f of x. You can do it with h or g or z or any of them. Because again, we're using these f of x, h of x, g of x to refer to a specific function. It's just a way to name it. Now, what is our value of k? 3. Would it be positive or negative? Positive, because we're going up. So h of x is what? Now again, we could have the parentheses around it because we're plugging it into the function. But is there anything in front of those parentheses? No. So we don't have to have them here. Because we just need to make sure to be careful if we plug something in and there's a number or sign in front of it, that it does get translated to that entire function. That's it. So again, if we take these combining transformations, one transformation at a time, that's what's key to these here. There's one more. The assignment is in Google Classroom already, so you can pull it up there and get it. So we're going to look at this. You're good. Let G be a translation 6 units down, followed by a reflection in the x-axis of the graph. F of x equals the absolute value of x.
So does it matter what order we do it in? Like, are we going to have to know a certain one before we can get to the other one?
Always go in the order that they're shown, or that they're presented.
So you're not going to switch it up.
If I do write it in a different order, it doesn't matter which one came first. It's always about which one comes first. Because here, realistically, the translation up and down and the reflection across the x-axis will show out a different result if we flip these. So here, the first thing we want to do is our translation of 6 units down. So we could call it h of x. So we'll call this first one h of x, which is our f of x plus k. Yeah, because up and down is k. We're still using f of x because, well, our original function that we're talking about is f of x. Now the value of k is what? Because where are we going? It's negative 6, because we're going down 6, so it would indeed be negative 6. So what would f of x be? Well, what? The absolute value of? Yeah. So we could put it in now, or we could have rewritten it as f of x and then wrote it in at the next step. Either one works. So that is our translation of 6 units down. Now what do we need to do next? Reflection in the? So it'd be negative f of x, or because we called the first, because now we're talking about this function down here, not this one up here. But as long as you guys can keep them straight, that's what's key. Okay?
So that over there with the h of x, that's the whole problem.
So we want to do a reflection in the x-axis. So reflection in the x-axis when we're doing it to f of x is negative f of x. Oh, yeah. Since we're not talking about f of x anymore, we're talking about this function h of x.
So you just like put that over there and made it
Yeah, because we're doing x-axis. If we'd applied it to the y-axis, we would have said h of negative x. Because the f in all those just means that we're applying this to the function f of x. If we'd have said it was all being applied to h of x, all the f's on this board would be h's. Does that kind of make sense? It's just a way to name. So now we just need to replace h of x with its function, which is? And last but not least, we have to distribute that negative. So that would give us negative. And that's our final answer. Any questions on this here? You might probably have a few once you try a few. Yeah. If you do have questions, please ask.